In this lesson, we're going to continue looking at tangents and normals, and we're going to do a little bit of problem solving. We're going to try and figure out some things using those ideas in some different situations. So, knowing the slope, the gradient, the derivative allows us to figure out points. You can go backwards. And that allows us to find where the things happen. For instance, if I know something has a derivative of 5, oh, I know the slope's going to put 5, I can figure out where on the graph that happens. And if I know it's a horizontal tangent, oh, it means it's a derivative of 0, a slope of 0. And so our problems today are going to work backwards for these situations. All they are is examples. Let's take a look at the first one. At what point on the function does the tangent have a gradient of 2? In other words, where is my derivative equal to 2? Well, I can solve that if I have a derivative. My derivative for this function is 2x minus 4. I want to know where it comes out to 2, so I can set it up to solve. I put numbers on one side, letters on the other. And I know it happens where x is 3. The question is at what point, so I can find points by going back to my original function. If I put a 3 in for my x's, into my little calculation here, I end up with a point of 3 and 4. So on this parabola, the tangent, if I were to actually draw it out, would be a slope of 2 at this point, 3, 4. And you guys can try the next one. Give it a pause, see what you can do. So given a function, write down the coordinates of any point where the graph has a 0 gradient. 0 gradients mean derivative equals 0. So we take our derivative, and we're going to get 2x plus 16x to the negative 2. I want to know where it comes up to 0, so put 0 in. To make this a little bit easier to work with, I'm going to take my derivative and put it back into fraction form. The reason I do that is whenever I have a fraction form, I can cross multiply. So think of this as 1 times 16 this way, and 2x times x squared will give us, 16, negative 2x cubed. I can solve that. Divide both sides by negative 2. That gives me x cubed. And to get x, I can take the cube root of negative 8. Oh, x is negative 2. Again, it asks which points. I can find points if I go back to my function. My function at negative 2 is negative 2 squared minus 16 over x, or in other words, over negative 2, which is 4 plus 8, 12. So the point is negative 2 and 12. That's where I have a flat spot. All right, let's try some more problems. Two functions are given, f and g. Determine where they have the same gradient. In other words, where is f prime equal to g prime? Because of those points, they have the same tangents. So let's find them. F prime at x. 2 times a quarter makes 2 quarters. X. G is derivative of this. That's a nice one. 1 times x is just 1. And there's my derivative. So in other words, I have 1/2 x equals 1, or x equals 2. Oh, I figured out the value where they have the same gradient. It happens when x is 2. And consider the next function. It's a parabola. Let P be a point on the curve. At P, the tangent to the curve is parallel to this line. Parallel means same slope. Well, same slope is 3. So I know my slope is 3. If I'm talking about tangents, I know that f prime at x has to be 3. Where does this happen? Well, my derivative is 2x. I want to know where it comes out to 3. So I've got this equation. 3 over 2 is x. In other words, x is 1.5. This happens at 1.5. But I was asked to find coordinates. So if I want to find coordinates, I have to go back to my point, or my function, sorry, and plug in 1.5. So 1.5 squared minus 4, that's going to give us negative 1.75. So P, the x value is 1.5, and the y value is negative 1.75. There's my point. All right, let's try some more. We can also figure out original equations if we know some things about the derivative. So find a, and I've got this equation that has an a in it. It has a tangent with gradient 2 at the point where x is negative 1. In other words, my derivative at negative 1 is 2. That's really handy information. It's all about derivatives. Let's take our derivative. 2 times a, I don't know what a is, so it's going to be 2a with an x plus 6. But what do I know? I know when x is negative 1, the derivative comes out to this. So I can put 2 into my derivative, and that happened when x was negative 1. Well, this is an equation I can solve. Bring the 6 over to the left, multiply all this together, gives me negative 2a. So a is 2. Hey, look, we solved it. And you guys can try the next one. So pause it and give it a try, see what you can do. The tangent to fx at the point negative 3 and 8 has a gradient of 9. So what's this trying to tell us? I've got a point. That's handy. I've also got a derivative. It tells me at negative 3, the gradient is 9. Well, let's work with some derivatives. My derivative is negative 6x plus a. But I know that my derivative comes out to 9 when x is negative 3. Well, that allows me to solve for a. 9 minus 18 is a is negative 9. So now I have an equation, but I know some more stuff about this equation. F at x is negative 3x squared minus 9x plus b. I filled in the a value, right? We knew what it was. Well, I can solve for b by using a point, an x and a y, which I have. I know y is 8 when x is negative 3. So I can solve this. I've got x equals negative 27 plus 18 plus b. And whenever we have points, we can always plug them in and solve for things, right? See what happens. So I'll get 8 plus 27 minus 18 is b. And in other words, b is 17. Oh, sorry, math mistake in there. 9 times 3 doesn't make 18. 9 times 3 is 27. B is 8. Sorry about that. Okay, so we've got A, we got B. That's what we're asked to find. Last one. The graph alongside. P is the point with x coordinate of 2. That's good. That's helpful. I can put a 2 in here and 2 in something. I know what the something is. I also notice my equation has an a in it, so I can't even plug in the 2 and figure out what it is. I'm missing part of the equation. Find, the tangent has a gradient of 1 at P. So in other words, if I were to draw this tangent, I know the slope is 1. In other words, for part A, f prime at 2 comes out to 1. Well, let's see if we can find the derivative. I know it's going to come out to 1. 3 times 1/2 x, that gives me 1.5 x squared minus 2x plus a. Okay. Oh, I also know that this happens when x is 2. So if I put the 2 in for the x, the only thing I'm missing is a. That's kind of handy because I can solve for a now. So let's do the math here first. 6 minus 4. 1 minus 6 plus 4 is a. A is negative 1. Well, that was not too bad. Part 2 says find the coordinates of P. I can do that by using my original function at 2. That's what we were told, right? X is 2. And now that I know A, I have all the parts and pieces to solve this equation. A was negative 1. And put that all into our calculators. And we get a number like, hopefully, 2. So P is 2. Okay, there's part A done. Find the equation of the normal. Oh, okay. We know things about normals. We know that normals are perpendicular right through there, right? Or roughly about that. They're perpendicular tangents. Our tangent at a gradient of 1. Well, what's perpendicular to 1? If I flip it over, I get 1 over 1, and if I change my sign, I get negative 1. So my slope is negative 1. I want to find the equation of this normal. So mx plus b, I fill in my slope, and I have a point P. So I can put 2 in for the x and the y, and solve for b. So our normal is negative 1x plus 4. That wasn't too bad. Okay, part C. Find the coordinates of the point Q where the normal meets the curve again. So obviously I've drawn my picture slightly wrong here. This line, if I actually drew it accurately, is going to meet the curve again. Maybe it's going to meet over here, maybe up here somewhere, maybe it meets over here, maybe it hits there again, maybe it hits 2 spots. I'm not quite sure if I draw it properly. But hard to do it graphically, so let's do it algebraically. Where does my curve hit my normal? Well, my curve has an equation, 1/2 x cubed minus x squared minus 1x plus, just write down the equation right from the top here, okay, plus 4. My normal also has an equation. It's negative 1x plus 4. I want to know where these two things meet. If they meet, then they must be equal to each other. So let's set them equal to each other. Something kind of handy you might notice right off the bat, 4 and 4, negative 1x and negative 1x, they cancel out. So I'm left with 1/2 x cubed minus x squared to solve. And I can solve that by factoring. If I common factor out the x squared, I'm left with 1/2 x minus 1. So I want to solve this. My zeros are either x equals 0 or 1/2 x minus 1 is 0. In other words, x is 2. Now, we already know at 2 what's happening. At x equals 2, that's the point P. So the point Q must be the other one. This is P. This is Q. 0, and if I put 0 in to find the point, if I put 0 in for all the x's, I'll be left with 4. So Q is the point 0 and 4. Okay. And there's some problem solving, some things we can figure out using the ideas of derivatives, points, functions, and their graphs. Okay, the homework is in a handout again. It's in your books. Answers on the website. Take a look at them. If you're stuck, come see me. And we're going to start moving into sort of more higher level things. We're going to look at graphs in a more specific way, and then into word problems.